functions all around us. In nearly every physical phenomena, we observe that one quantity depends on another. For example, your height depends on your age, the temperature depends on the date, the cost of mailing a package depends on its weight. We use the term function to describe this dependence of one quantity on another. That is, we say that height is a function of age. How tall you are depends on your age. Your age doesn't depend on your height. Temperature is a function of date. The temperature is a lot different in July than it is in December. And cost of mailing a package is a function of weight. Now, some of these have nice simple rules and some of these relationships don't. The U.S. Post Office uses a simple rule to determine the cost of mailing a first-class parcel on the basis of its weight, but it's not so easy to describe the rule that relates height to age or the rule that relates temperature to date. We will focus on the functions where it's a little easier to write the rule most of the time. A function is a rule. To talk about a function, we need to give it a name. We use letters such as F, G, and H to represent functions. For example, we can use the letter F to represent a rule as follows. F is the rule, square the number. So if we write F, this right here is read as F of 2. When we write F of 2, we mean apply the rule F to the number 2. Since the rule is square the number, we would square 2, which is 4. If we had F of 3, we would square 3 and get 9. If we had F of 4, we would square 4 and get 16. And in general, F of x equals x squared is the rule. So a function f is a rule that assigns to each element x in a set A exactly one element called f of x in a set B. Right? This part is in your notes. Let's make that a little clearer so it will make a little bit more sense to you. All right, so we're going to illustrate what that means. All right, so this is not a function. This is a relation. Oh, and you have let me write through the notes and I will mark what I want you to write, because you don't have you can add a sticky note for more space, but you don't have a ton of space. I'm just going to have you put a little bit of information. So this definition is already in your notes. And now just illustrate. This would not be a function. So if I had 5 matched to 4 and 7, and maybe we have 2, and that's matched to 8, that's not a function because each element in set A is not matched to exactly one element in set B. So I've got one number, one input value, this would be the input, matched to 2 outputs. So that's not a function. And actually this is called a relation. Actually, you could fit this on the side. Now let's look at an example of a function. This would be a function. Right? So if 5 is matched to 4 and 7 is matched to 4, and 2 is matched to 8. That is a function because each value in set A is matched to only one value in set B. It doesn't matter that 2 values in set A are matched to the same value in set B, so long as you've got, given my input, I have to know where to go. So given 5, I go to 4. Given 7, I go to 4. Given 2, I go to 8. In the first example, the relation, given 5, do I go to 4 or 7? I don't know. This is also a function. All right, so 5 matched to 4, 7 matched to 9, 2 matched to 8. Here, each member of set A is matched to one member of set B, and each member of set B is matched to one member of set A. This is a special kind of function. It's called one-to-one. That'll be important in the second semester. I just remembered that I had put an extra sheet in your notes for extra information. So go ahead and add this part to your notes. So if you are watching it live, I will pause for you to write it down. If you are watching it on the video, just pause the tape and write this part down. All right, so if you go to the end of the section, there is a blank page, and then you can put this information in. You do not need to put the top part in. The definition of a function is in your notes, just the part I put in black writing at the bottom and that I identified. All right? Just so that when we talk about function, you know what a function is and what a function isn't. Okay. A function consists of a set called the domain. So the domain is your input. So for instance, for our two functions, in the first function, actually in both of them, 5, 7, and 2 is the domain. That was the input. Those are also your x values, right? So when you think of an equation, the x values are your domain. So what you plug in is your domain. What you get out are the y values. That's your range, right? So the set called the range contains the outputs. They're your y values. And all of this is already in your notes except for the handwritten part. So you only need to add that to your notes. Everything else is there. So if we go back and we look at our example here, for the first function, the output is the range. So 4 and 8 is the range. In the second example, 4, 9, and 8 is the range. So your domain is what is your input. It's also the independent variable, and it's x. The range is your output. It's the dependent variable. It's the y. Right? So input is the independent variable. Output is the dependent variable. Input is also your domain and your x values. Output is your range and the y values. The output depends on the input. So what you get out depends on what number you plug in. And actually, that's what we're going to practice right now. So the definition of I have a recording box there. It keeps blocking when I'm reading. In the definition of a function, the independent variable x plays the role of a placeholder. For example, the function f of x equals 3x squared plus x minus 5 can be thought of as f of blank equals 3 times blank squared plus blank minus 5. What goes in the blank? Well, whatever number we want, right? Whatever we want to evaluate. So here we're going to evaluate, we're going to find f of negative 2, f of 0, f of 4, and f of 1/2. And when we are evaluating a function, we plug in the value for the variable and simplify. Right? So let's go ahead and try these. All right, so, and I'm going to go right across. I'm not going to be able to squeeze this all under A, B, C, and D. So first we'll do A, and then we'll do B, and then we'll do C, and then we'll do D, so that we have some space. So f of A means we're going, f of negative 2 means we're going to plug in a negative 2 everywhere we see an x. So we have 3 times negative 2 squared plus negative 2 minus 5. We're going to use order of operations. So remember, there's no real parentheses here. Parentheses are grouping symbols. The parentheses next to the 3 times, that these parentheses that are on either side of the negative 2 are not true parentheses. That's really a multiplication symbol. So I don't have any parentheses. Then exponents. We do have exponents. We have the square. So we'll square the 2 first. So this will be 3. Negative 2 squared, negative 2 times negative 2 is a positive 4. And so whenever you square a number, it becomes positive. Plus negative 2 minus 5. After exponents, it's multiplication and division. They're equal. We just do them left to right. There is no division, so there's just one multiplication to take care of. 3 times 4 is 12, so 12 plus negative 2 minus 5. And then addition, subtraction. They're equal, just go left to right. So 12 plus a negative 2, that's 12 minus 2, that's 10. 10 minus 5 is 5. All right, so notice I just went straight across. All right, plus a negative 2 and minus 2 are the same thing. So 12 minus 2 gives us 10. 10 minus 5 is 5. If you want to break this up into 2 steps, you can. Otherwise, you can just keep on going. Just remember, if it's a positive value, you're going to add it. If it's a negative, you'll subtract. All right, let us try the second one. All right, so oh, I forgot to write something very important in. What we were actually doing. We were finding 3 of negative 2. I'm sorry, I think because I saw it right above, I totally forgot to write it in. So you always want to write what you're evaluating. So just add that in. If you have to squeeze it in, it's okay because it was my fault. All right, now I won't forget this one. F of 0. So that means we're finding the value of the function when x is 0. So we have 3 times 0 squared plus 0 minus 5. So notice I plugged in a 0. Sorry, that is a 0. Everywhere there was an x. All right, well, we have no parentheses. This is all the same equation, so you're not going to have any parentheses. We'll start off with the exponent, squaring. If you square a 0, it's still 0. So we have 3, I'll write this step out, 3 times 0 plus 0 minus 5. And if you multiply 3 times 0, it's still 0. So if you add those together, the only thing that's not 0 is the negative 5. Right? That one was a pretty easy one because it's pretty easy to deal with a 0. All right, let's go ahead and do C. So C is f of 4. So we have 3 times 4 squared plus 4 minus 5. And you don't have to keep writing f of 4. You can write it once and then just put the equal signs. It's understood. The rest of the way, we're finding f of 4. So again, we're going to take care of the exponent. 4 squared is 16, so we have 3 times 16 plus 4 minus 5. We'll multiply 3 times 16, so that is 48, plus 4 minus 5, and then we'll just go ahead and add and subtract left to right. By the way, these are all in your notes, and I think you've got plenty of space to fit them in there. I think if you write them the same way I am, I think they'll fit in just fine. 48 plus 4 would be 52. 52 minus 5 is 47. And there we go. So the value of the function when x is 4 is 47. And then the last one, f of 1/2 is 3 times 1/2 squared plus, oops, I forgot what our number is, plus 1/2. All right, we're replacing the x with a 1/2. Everywhere we see an x, it's going to be a 1/2. And then minus 5. So again, we'll square. 1/2 squared. So if you're squaring a fraction, just square the numerator and square the denominator. 1 squared is 1, 2 squared is 4, plus 1/2 minus 5. So now we'll multiply. 3 times 1/4. So if you like, you can do that. When you're multiplying fractions, multiply numerator by numerator, denominator by denominator. 3 times 1 is 3. 1 times 4 is 4. So this is 3/4. Plus 1/2 minus 5. Now we're not going to just be able to add across like we did the other ones because we don't have a common denominator anywhere. We can change all of them to fourths because 4 is divisible by 2, and of course 4 is divisible by 1. The denominator for the 5 is 1. So let's just squeeze it up. Let's just put it up here. All right, so it's not in our way, and you can just do it up here as well. So, oh, sorry, we don't have to change 3/4. 3/4 is fine. The 1/2. So 1/2, if we multiply, we would have to multiply 2 by 2 to get 4. So if we multiply the 2 by 2, we have to multiply the 1 by 2, so 1/2 is 2/4. And you'd have to multiply 1 by 4 to get 4, so we're going to have to multiply the 5 by 4. 5 times 4 is 20. So 1/2 is the same as 2/4, and 5 is the same as 20/4. And if you divided a pie up into 4 pieces and you had 20 of them, you'd have 5 pies. So 3/4 plus 2/4 minus 20/4. When you add fractions, you just, or add and subtract fractions, you just add and subtract the numerators. You can only add, though, pieces that are the same size. So we can only add and subtract fourths. I'm just going to put the answer here rather than extend the page. You can do the same unless you have space. So 3/4 plus 2/4 is 5/4, because 3 plus 2 is 5. 5/4 minus 20/4 is a negative 15/4, because 5 minus 20 is negative 15. So negative 15/4 is our answer. And this is where I'm going to stop. And tomorrow we're going to look at more features of functions. Thanks for watching. Bye for now.